Hi everyone, today I'm going to be presenting TRPO and PPO. First, I want to discuss the problem these approaches try to solve, which is policy optimization. The goal in policy optimization is to find a policy parameterized by theta that maximizes the expected return. We can write this using this equation where a trajectory is sampled from the current policy. The challenge in this setting is that it's quite different from supervised learning, where the dataset is fixed. If we update the policy, then different actions are sampled, and those actions can subsequently result in different future states. So changing the policy changes the distribution over trajectories. This is the instability that TRPO and PPO try to address. So now I want to talk about a fairly naive solution to this. The most direct policy gradient method is reinforce. It basically says the gradient of the expected return with respect to theta can be estimated by taking the return of a trajectory and multiplying it by the sum of the gradients of the log probability of the actions taken. The issue with this particular formulation is that it's quite a noisy signal. The same trajectory level reward is applied to every action, even though some actions may have mattered much more than others. This is why it makes much more sense to use the advantage function, which is mathematically the same, this equation here, as that determines a specific action was better for a specific state or not. Now I want to talk about the performance difference lemma, which basically gives a more precise way to compare two policies, stating that the improvement from a new policy to an old one depends on the advantages of the action chosen by the new policy, weighted by the states the new policy visits. So if a new policy puts more probability on positive advantage actions, it should improve over the policy, and if it puts less probability on negative advantage functions, it should also see an improvement. However, this exact expression depends on the new policy's discounted state visitation probability. So before we roll out the new policy, we do not actually know this distribution, so we need a surrogate. TRPO is one of these examples. TRPO replaces the unknown new policy state distribution with the old policies. So instead, we evaluate the new policy only on states visited by the old policy. The probability ratio tells how much more likely the new policy will make a sampled action. Multiplying this by the action here tells us whether that change is positive. However, this surrogate over here only makes sense if the new policy stays relatively close to the old one. TRPO enforces this with the KL divergence trust region constraint, effectively improving the surrogate without moving the new policy too far. The next approach is PPO, which keeps the same basic idea as TRPO, so using a probability ratio times an advantage estimate here. But instead of solving a constraint optimization problem with a hard KL constraint, PPO clips the probability ratio instead. The clipped objective prevents the policy from getting extra benefit by changing the probabilities too much. If an action has a positive advantage, PPO encourages increasing its probability, but only up to roughly 1 plus epsilon, and it would be 1 minus epsilon if the action has a negative advantage. So PPO is a lot simpler and a much more practical approximation to TRPO, and it is used much more frequently in practice due to implementation optimizations allowing faster convergence. In terms of empirical results, TRPO showed that constraining policy updates can lead to stable learning on challenging tasks like simulated locomotion and Atari. PPO then showed that a simpler clipped objective could retain much of the stability. In PPO's continuous controlled experiments, the clipped objective performed much better than unclipped and KL penalty variants, and PPO often matched or outperformed TRPO and other baselines. So on these graphs, it's pretty visible that PPO's clipped objective tends to converge a lot faster than other approaches. So while TRPO gives a more theory-motivated, stable update, PPO gives a simpler method that is often easier to train in practice. In terms of open questions, the main one is the gap between theory and practice. TRPO is motivated by the monotonic improvement guarantee, but the practical algorithm still relies on quite a few approximations. PPO is even more heuristic because it replaced the constraint with clipping. However, it tends to still perform better in practice. Later work by Engstrom et al. In 2020 suggests that PPO's success may not only come from the clipped objective and that implementation details matter a lot. They test this using several ablation studies. Therefore, an open question of these papers would be how we can identify the true source of improvement in policy gradient algorithms when performance so heavily depends on the implementation details. Thank you.